Okay, so now let's see now we are going to see the reaction of a particle or a body. Let us start with this note. A body falling under gravity experiences an acceleration of 9.8 meters per second. This is the gravitational force. And based on Newton's second law, there is a force causing acceleration called the weight of the body. So this force that is causing that acceleration is called the weight of the body. Remember, we said in one of the implications that the force and the acceleration of the body are always in that direction. So if this is going to be accelerated downwards, it means that there is a force, and that force is going to be the weight of the body. That's why it's going to be moving it downwards. Every particle with weight mg has a normal reaction acting on it. The normal reaction R is always perpendicular to the surface at which the body is resting. Simple terms is always perpendicular to the body. Weight of the body is always acting vertically downwards. Let us see case 1. Consider a body of mass mg kilograms resting on a smooth horizontal surface. Now it's that this one is resting at this surface. So this is the body of mass m kilograms. Of course, as long as it's a body, there is always a reaction which is going to be acting upwards against it. Now this is going to be always the way. Remember, every body or every particle which has mass is going to be having weight. How do you get weight? You get mass minus the gravity. Okay, so after this, remember this body is resting. It means that the resultant force will be equal to mass minus the acceleration. But remember, our acceleration is 0 because the body is resting. And to simplify this, so that our R is going to be equal to md as long as this body is on a horizontal plane. Now, in the next case, we are going to use this idea. Remember when we are resolving forces, so recall, if we have a force acting downwards like this, we can resolve it like this and then like this. So, this theta is adjacent to this. So this one becomes a force because adjacent goes with the force. Then this force is going to be like this. So this force is going to be parallel to this. So this force will be, and it will be opposite. It will be opposite to this angle. So it will be F sine theta. Or there are two ways. Or you resolve like this. If the force is going like this, you resolve this way. Then you also resolve this way. So when this makes an angle, this becomes an adjacent, and then this becomes the opposite. We are going to use that idea in the next case. Consider a body of mass m on an inclined plane making an angle theta to the horizontal. The body is resting. Now, if we remember, if we say the R is always perpendicular to the body or to the plane on which the body is lying. So that's why you have our R there. And always we say our weight is going to act vertically downwards. Now, from there, I want to resolve this mg. It means that I have to create an angle which is right angle here, or is this angle is right angle there between the forces. We say the easiest way of resolving is when we resolve these forces perpendicularly. So now, if I draw this force here like this, remember this is I'm just putting it there. It means that now this is going to be 90 degrees there. It's going to be 90 degrees. Also, meaning if I resolve it like this, now we are going to resolve it like this. We have always this force acting like that, and then we shall be having this force acting like that. On this body, we are basing on this body now. This body. That's why when I do this, it means that in simple terms, I'm doing, because that force is in the plane, I don't want you to assume we are resolving. We on this body. That's why most cases you are going to find this diagram even like that. Okay, so after doing that, allow me to first clear this away so that we start serious work. Now, after resolving, that is just a disk. You're not doing anything much. Now, you can see that we have, after resolving, we have created a right angle triangle, this one here. But we are assuming it's this, okay? Now, you see that now, if this one, now remember this force is always to this horizon, so it's going to be perpendicular to this. So if this is theta, this is 90, it means that now this one, this angle here is going to be 90 minus theta. Okay? If this is 90 and this is theta, this one is going to be 90. It means when you add this angle plus this, you should get 90. Because the angle sum of the triangle is 180 degrees. Now, if this one is 90 and this one is 90 minus theta, it means that now when I add this and this angle here, this should be now giving me theta. Because this is 90, so when I add this plus this, I should get the 90. So now, when you look at this, now you can able see that in simple terms, if I'm pulled out this triangle here, this one here, I mean if I pull out that, you can able see what I'm going to be having is something which is going to look like this. If I'm pull it out here, hope you can able see what I'm going to be having there. That's what I'm going to be doing. This is going to be my force acting like that. So this is our mg, the weight, and this one is going this way, and this one is going like that. And this is our theta. I think now we are at this case. Now you can see that this one, okay, if you want, you can even put this idea there. Like, remember, if I do that, this one here, this force is going to be parallel to this. This is parallel to this. If I do this, this is going to be parallel to this. Now, so this one is adjacent. So this one is going to be mg. It's adjacent, then cos theta. Then this one is that it's opposite. So this one is opposite. It's going to be mg sine theta. Remember this was in power to this, so meaning that this one is also going to be mg sine theta. And so there we have resolved that component. So meaning this one is going to be mg sine theta, and then this one is going to be mg cos theta. And so we have resolved that g is force here. So in simple terms, whenever you are given a particle on an inclined surface, always we are going to say this is going to be the force acting the plane like this. It's going to be mg cos, then this one is going to be, so that's the derivation. Now, because the body is resting, our resultant force, let us say along the plane, if you are resolving along the plane, along the plane, you start along the plane, we are going the other side. Now, if we are assuming that there is a force acting on this particle, like this F, so you get, remember, our resultant force is always equal to M-A. Now, our resultant is going to be F minus this along, because I'm resolving along the plane. So we have F, then minus our mg sine theta is going to be equal to the mass times acceleration. Our A is going to be 0y, resting body. So there is no acceleration. So this one is going to be 0. So that we have m minus equal to 0. Our m, if you take this side, our x is going to be mg sine theta. As simple as that. Now if you resolve normal to the plane, normal to the plane. Normal means force is perpendicular to the plane. Normal to the plane is that now the resultant still our Fr will be equal to MA using the Newton's second law. So you start normal to the plane, we have this force going inside and then this going inside. So you have R minus mg cos theta equal to 0. So from there, our R will be mg cos theta. Now, after this, now the body is just resting. So these are the three things we can able. This is how we can resolve that. The idea is you need to know that whenever you have this force like this, you need to know that we're going to resolve it like this. you have seen why this angle is now theta also, basically. Okay, so now after doing that, we are going to see now the cases. We are going to consider the first case when the body is just resting, like we've seen here. The second case we are going to consider when the body is moving but at a constant speed. Then in the last case, we shall see a body moving or sliding down the plane. That would be our third case. Along the plane, it can be going this side or it can be going this side. It depends on how you want to resolve it. But you always follow the direction of the acceleration. So that's it. Now we are going to see case 1, case 2, and case 3 of the next lesson. Please don't forget to subscribe to the channel. See you there.